video we are going to discuss about the topic and the problems related to the wave speed. What is wave speed and what is the equation for wave velocity in a stretched string, and what is the expression for velocity of longitudinal wave in air and in any other medium, how we can write, and which type of questions will be asked in the examination like JE, Neet, Eamcet, etc. Let's discuss. Here wave speed is depend upon the characteristics of medium. Wave speed depend upon characteristics of medium. So why? Because here even though the waves which are having different frequencies and wavelengths, they can move with the same speed. Clear what we are saying? Wave speed can depends what? Characteristics of medium. Characteristics of medium. So how we can say that? For example, all electromagnetic waves, they have different wavelengths and different frequency, but when they are passing through the vacuum, they should be all are moving with speed of 3 into 10 power of 8 meter per second. Even though electromagnets have different velocities, different wavelengths and different frequencies, but they can move with the common speed. Clear? And in the same manner, in longitudinal waves including sound waves, there should be all longitudinal waves, they can move with speed of 330 meter per second in air. So that's why here what I have to say, the wave speed should be depend upon the characteristics of medium. And now what is the relation between the frequency, wavelength and wave speed? So generally what we know here, V is equals to nu lambda. That is the expression for wave velocity or wave speed. V is equals to nu lambda. From that what right here, nu is equals to V by lambda, or lambda is equals to V by nu. So these are the relations regarding the wave velocity or wave speed. Clear? V is equals to nu lambda. From that what right, nu is equals to V by lambda, or lambda is equals to V by nu. What is the relation between these two? Lambda is proportional to 1 by nu. Inversely proportional. How these two are? Already what we know, V is equals to 330 meter per second. In air, all the waves are moving, all the longitudinal waves can move with the speed of 330 meter per second. That's why what you have to write, lambda is proportional to 1 by V. So here, when frequency is more, wavelength is less. When frequency is less, wavelength is more. In general, female voice has more frequency, but it is least wavelength or less wavelength compared to male voice. So male voice has least frequency and that should be having more wavelength. So this is the relation between the frequency and wavelength. Here the frequency of the wave should be depend upon the source and at the same time the wavelength. In case of wavelength, it is the adjustable thing. So this is simply about the wave speed. Based on this one, we will discuss one problem. Let's see here one problem. It is the speed of sound in air is 330 meter per second. Find the minimum wavelength of audible sound in air. Speed of sound in air is how much? It was given 330 meter per second. Find the maximum and minimum wavelength of audible sound in air. So what he was given? He was given velocity of sound. Speed of sound in air is what? It is 330 meter per second. What you have to find out? Minimum wavelength. Lambda minimum we have to find out, and wavelength maximum wavelength we have to find out. But the given clue is what? Audible sound. We know that audible sound frequency range what is 20 hertz to the 20,000 hertz. 20,000 to the 20 hertz to the 20,000 hertz. That's why here this is the minimum frequency and this is the maximum frequency. Maximum frequency. Already we discussed what it is. V is equals to nu lambda and lambda is equals to what? V by nu. P by nu. So how these were? Lambda is proportional to 1 by nu. 1 by nu. Inversely proportional. Inversely proportional. So when nu is maximum, lambda is minimum. Nu is maximum. Okay. First one. When nu is maximum, then lambda is minimum. Lambda is minimum. That's why we can write the formula. Therefore, lambda minimum is equals to V by nu maximum. Nu maximum. Then lambda minimum is equals to what? V means what? Velocity of sound. What was given? 330 by nu maximum. What is 20,000? 20,000. Clear. Then what is 33 by 2 into 10 cube? 2 into 10 cube. 33 by 2 into 10 power of minus 3. So 2 ones are 2 6 are and 2 ones are 2, 13, 2 6 are 12, again 16.5. Then what is lambda minimum is equals to what? 16.5 into 10 power of minus 3. It means that 16.5 by 1000. Then what do you get here? 0.0165 meters. 0.0165 meters. This is what? Minimum wavelength. Minimum wavelength. Now what you have to find out? Another one. As maximum wavelength. Maximum wavelength. For that, lambda maximum is equals to what, right? V by nu minimum. Nu frequency is minimum. V value is what is 330. And nu minimum. What it is nu minimum? 20 hertz. So as what it 33 by 2. That is equals to what? 16.5 meters. So therefore maximum wavelength is what? 16.5 meters. And minimum wavelength is what? 0.0165 meters. Let's see for formula for speed of a wave in a stretched string. So speed of transverse wave in a stretched string or in a string. So the formula is like this. Here V is equals to under of T by mu. V is the velocity and T is the tension, that is equals to nothing but mg. And now what is mu? Linear density. Linear density. Linear density. So mu is equals to mass per length. And you can write like this also, m by L into A into A. Then there is no change in value. Then what you have write? M A L into A means what? V here. Volume. Then m by V into A. So what is m by V? Mass per volume density. Then mu is equals to rho into A. Mu is equals to rho into A. Therefore what have write formula? V is equals to under of T by rho into A. This is the another form of the speed of sound wave. Speed of sound wave in a medium. In a medium is given by the formula V is equals to under of B by rho. V is equals to under of B by rho, where V is the delta P by delta V by V. Modulus of bulk modulus. B is what? Bulk modulus. That is what here simply volume stress by volume strain. Volume stress per volume strain. So V is equals to under of B by rho. Velocity or speed of a sound wave in a medium. Then the speed should be depend upon the two factors. One is the elastic properties. Elastic properties. And inertia properties. Inertia properties that should be depends on. So now speed of sound in gas. In gas, initially what we take, V is equals to 100 of B by rho, and that should be based upon the isothermal process, isothermal properties. Newton can give an explanation for bulk modulus is nothing but pressure. Therefore, V is equals to 100 of B by rho. That is what here, V is equals to 100 of now P by rho. So this is what we call here Newton equation. Newton equation for wave speed. So in this case, Newton considered the isothermal properties. Based on that, he was explained that bulk modulus is equals to the pressure. Clear? So after so many years, again that equation should be modified by the Laplace. Who is that scientist? Laplace. He was given explanation that such that the same equation can be modified like this. V is equals to here under root of gamma P by rho. What is gamma here? Ratio of specific heats, and that value should be measured as here 1.41 P by rho. Gamma value is what? 1.41. And he was explained Laplace can take against the process of adiabatic process condition, adiabatic properties. So in this case, isothermal properties of medium, and in this case, adiabatic properties of medium considered by the Laplace, and based on that he was calculated this equation as V is equals to under gamma P by rho. So this is the matter what about the speed of sound wave in a medium. So regarding the problems, these are the most important formulas you have to do. You have to remember these formulas to do the calculation. These are the equations in case of a medium, like gas or liquid like that. If you can take solid, how the equation we can write means, so in case of solid, speed of the wave in a solid, that should be given by the formula V is equals to under of Y by rho, where Y is the Young's modulus and rho is the density. What is rho is the density. So you have to remember this formula. This is also important. Let's see the one problem. The volumetric strain of water at a pressure of 10 to the power of 5 Newton meter square is 5 to the power of minus 5. Determine the speed of the sound in water. Density of water is 10 cube kg meter inverse 3. 10 cube kg meter inverse 3. That is the problem. So what he was given? Volumetric strain. How much is there? 5 into 10 to the power of minus 5 at a pressure of 10 to the power of 5. And what we have to find out? Speed of sound in water we have to find out. And what he was given? Density was given 10 cube. So that's why here that formula, speed of sound is given by the formula V is equals to under of B by rho. Here air or water, for that formula is here V is equals to under of B by rho. What is V here? Bulk modulus. What is bulk modulus? So, and that should be given by here V is equals to S P by delta V by V. So volume stress by volume strain. Clear. So what was given? P is the 10 to the power of 5, and he was given what is volume strain how much? 5 into 10 to the power of minus 5. 5 into 10 to the power of minus 5. That is equals to 1 by 5 into 10 to the power of 5 into 10 to the power of 5. Clear? 1 by 5 means what? 0.2 into 10 to the power of 5 into 10 to the power of 5. And it should be written here 2 into 10 to the power of 4 into 10 to the power of 5. And what right here? 2 into 10 to the power of 9. Clear? So 2 into 10 to the power of 9 is the B value. And now substitute here V is equals to under of 2 into 10 to the power of 9 by rho. This value what it is? 10 cube is was given. Then V is equals to under of 2 into 10 to the power of 9 into 10 to the power of minus 3. Then V is equals to root 2 into 10 to the power of 6. Then what it here? V is equals to root 2 into 10 10 cube all square. 10 cube all square. What do you get here? V is equals to root 2 into 10 cube, it is there. Clear? Then what it is here? V is equals to 1.41 into 10 cube. So 1.414 into 10 cube. Then what it is here? V is equals to 1414 meter per. Let's see another problem. Determine the speed of sound waves in water and find the wavelength of wave having frequency of 242 hertz. Take bulk modulus of water is 2 into 10 to the power of 9 Pascal. Determine the speed of sound waves in water. That's why the formula is what? V is equals to under of B by rho. So already we know that density is what? V is equals to here B by rho. B value is what it is, was given 2 into 10 to the power of 9 by rho. Rho is what? 1 into 10 cube. 1 into 10 cube it is there. Then simply here V is equals to 2 into 10 to the power of 9 into 10 to the power of minus 3. Then what you get here? Under root 2 into 10 to the power of 6 we will get. That means what? Root 2 into 10 cube we will get. So then what root 2 means here? 1.414 into 10 cube. That is what? Here 1414 meter per second. This is the velocity. And now what we have to find out? We have to find out the wavelength also. Wavelength. Formula what is? V is equals to nu lambda. Lambda is equals to what? V by nu. And lambda is the speed of wave is what? 330 by, sorry, already we have 1414 by nu. Frequency of is given 242 1414 by 242. 2 7s are 2 1s are 2 2s are 2 1s are. So lambda is equals to what? 707 by 121. It is almost all equals to 5 meters.